In this lesson, we're going to discuss vectors, and we'll start this topic. We'll want to look at vectors. What are vectors, and how can we calculate vectors? So that is what we are going to do. And how do we represent vectors? So basically, it will be an introduction to vectors, and we just want to look at the early concepts when it comes to vectors. So getting into it, what is a vector? So when we talk about a vector, we are talking about a something which has got magnitude and direction. So these are the two things that we have to think about when we are talking about vectors: the magnitude and direction. And these properties have to be given in order for us to specify a vector. For example, thinking about a vector in a mathematical sense, it has got two things. That is, if we talk about direction, we're talking about where that vector is pointing and how much of that vector do we have. So in mathematics, we can represent vectors by drawing with a line like that. So we can represent a vector by drawing a line and some arrowhead. So the length of this line represents the magnitude of the vector, of course with some appropriate scale, and the direction of the line represents the direction of the vector, and we call this a directed line segment. A directed line segment. So in a mathematical sense, when we represent vectors, this is what we are talking about. The length of this line represents the length of the magnitude of the vector, and the direction where it's pointing represents the direction of the vector. So the vector that we have on screen here is pointing to the right side. So this is the direction of the vector, and then this is the magnitude. Given some appropriate scale, we can label this. We can see this the magnitude of this vector 2 centimeters or 3 units or whatever it is that we want to put. So this is how we represent vectors, and so that is how we can define a vector. So a vector has both magnitude and direction. That is what we have to know, that the length represents the magnitude of the magnitude of the vector, and the direction of the line represents the direction of the vector. So two things. So now, how do we represent vectors? This was just the definition of a vector, mathematical definition. Now, how do we represent vectors? So here we're going to talk about representation of vectors when it comes to mathematics, and the notations that we use to represent vectors. So we already know that we can represent a vector by drawing a line in the direction of that line. So for example, we can draw this vector here to represent this line, in the direction of the line to represent the vector and direction of that vector. So this direction here, we can say is going to the right up, it's to the right and up. That is the direction of this vector, and the magnitude of this vector is the length of the line. So how do you represent a vector? So remember, vectors need to have two things. They need to have a magnitude and direction. So for us to clearly label directions in space, especially when we usually put 2 points, we look at the tail of the the vector and the head of the vector when you're interested in these two things. So we can label where the tail will be where the vector is coming from, and the head will be where the vector is going. So we can label this as where the vector has ended up, now it's going. So we can label the tail as A, and we can label the head as B. So these are two things we could be interested in when it comes to vectors, because we're looking at direction. So hence we can label that the direction of this vector is from A to B, and we can represent this. We can represent this by writing A, B with some vector arrow on top. So this represents that we have a vector AB which is in the direction of AB, starting from A going all the way to B, or ending to B. The tail is on A, then the head is on B of this vector. So now this is the number one way we can represent vector, or denote on notation used to represent vectors. So this is the first way of representing a vector. So we say the line, we draw the line, and then the head, so we have the tail, and the head is A is the tail, B is the head, and we represent this as A, B with some vector arrow on top. Now this is not the only way we can represent a vector. The second notation, we can represent the same having the same vector. Let's say A is the head as well, again, and B is the tail. We can represent this by, sometimes can be denoted by just writing a board A. So board A could be used to denote a vector. Not just the board A, it could be any letter, but it should just be board. Most of the times that you're going to see these notations is in textbooks, because normally you cannot, when you're just writing freehand, it's very difficult to show a board letter. So it can be board A, board B, any board letter can be used to represent a vector. So this same vector, which we have represented as AB, could be represented as A or B or C or whatever letter we want, as long as this is board. So mostly you see these in textbooks, exam papers, and any printed text, because it's very easy to differentiate a regular A from a board A. So this can be used to represent a vector. The third way that we're going to talk about, which can be used to represent a vector, is we can have the same vector again, and then we will label it as AB once more. AB, because we know vectors should have a direction, so our direction is A, from A to B, and then we do not only represent it as AB with some vector arrow on top or a board A, we can also use the process or the idea of underlining, writing the letter, and then you underline it to represent that vector, or to denote the vector. So you can write, sometimes it's an italic letters, you italicize the letter and then you put an underline, or you underline the letter. So mostly when you writing freehand, or just writing, this is mostly what we use. We just write an A and then you underline it to represent that it's a vector. That is, if you choose your A to represent that vector, we can choose any letter. We can choose our B and then we underline it. We can choose our C and then we underline it. We can choose whatever letter we want, we underline it. So this will represent the vector AB. So from here you can clearly see that there are different ways of representing the vector AB. We have all these different ways that we can use to represent this vector. So hopefully this is not so complicated. So this is how we represent a vector AB. We can represent it as AB with some arrowhead on top, or just some bold A, or we can represent some A with underscore. So mostly you see, if it's in textbooks, you see some bold A to represent a vector, and in writing we see A with some underline. We see the letter and then we underline it. Alright, so this is how we represent vector. I think we can move on to the next part. And in this part, we want to talk about the types of vectors that we can have. So in this one, we'll say it's a zero vector. So this will just be like a definition for a vector. So a zero vector, a zero vector is a vector which has no magnitude in no direction. So we know that a vector should have a magnitude and direction, like we said in the earlier, in the beginning of this lesson. Now, when you have a zero vector, you don't have direction, you don't have magnitude. So we can represent or denote a zero vector with some just zero, and then we underline it, or we put some overline on top. So this is a way we can represent a zero vector. So zero vector simply means, okay, this is zero vector. So we don't want to say, oh, it's a zero vector, there's no vector, so we just say it's zero vector. So when you have a zero vector, just means that you don't have any magnitude for that vector and no direction. Okay, so as mathematicians, we want to define that one. So basically they're saying the zero vector. So the next type of vector we can look at is, we can't represent a zero vector, of course, we can't represent it. So we have what we call equal vectors. So equal vectors, these are vectors which are said to be equal, that they have the same magnitude and the same direction. They're going in the same direction and they have the same magnitude. So we can denote, or we can represent equal vectors unlike zero vectors. So if we have that vector and we can label this vector AB again, so we say this is our vector A, B, so this is tail, head, and we want to say maybe this is the vector A with some other line there. So we can denote, so it's AB, and we've denoted this or represented it with some A and some underline there. So this vector can be equal to another vector if some vector somewhere has got the same direction and the same magnitude to this vector, then this are said to be equal. So it doesn't matter where it's positioned, it can be free, it can be free space. So it could be that vector down there. Doesn't necessarily have to be the same on the same position. It just has to have the same direction. So we can say this as A prime, this one as B prime. So this will be and the same magnitude. So these two vectors are said to be equal vectors. They have the same direction and the same magnitude. So that doesn't necessarily mean that they have to be equal or aligned perfectly for them to be equal vectors. No, they just need to have the same magnitude and the same direction. If you wanted, we would have put this vector somewhere here and then someone there. It would still have been an equal vector to the vector AB because it would be in the same direction and have the same magnitude. So mostly in the exams, if you have an equal vector, or textbooks, probably you put some vector here and another vector down here. So these two are equal if they have the same magnitude and the same direction. So this was just an introduction to vectors, and we can start off from here. We talk about equal vectors, free vectors, and define what a vector is and how to represent a vector. Next, we are going to talk about free vectors and how to find the magnitude of a vector. So see you in the next lesson.